In this video, we're going to be considering the third problem, okay? To solve this question on the board, still on electric field, and in this case, we are given the coordinate of free space 0, 0.1. Now, in our last few previous video, we talked about the other aspects. We had A, B, and C problems solved, okay? Still a coordinate of free space. But you notice the problem kinds of get a little bit difficult as we go on, and this is the third video, I think, on this same problem. So I'm going to be solving this problem on the board, but for the coordinate of free space 0, 0.1. Okay, so first things first, remember what we have to do is draw out the diagram that illustrates this example. Okay, so remember by having something like this, here remains our origin 0, 0, and then we have 0.1, and then we have 0.1 for the negative x-axis and then for the positive x-axis. If you don't understand how these things are being done, like I always say, watch the previous video we've done, okay, for the case 1 or part 1 and case 2 for this same question as well. It will help you understand before you proceed to watching this one, okay? So what we are going to do is solve the same problem, and in this case the coordinates given to us is 0, 0.1. Okay, 0 is that on the x-axis, which means on the x-axis it is 0.0. We're going to start from here, okay, and then 0.1 for the y-axis. So vertically upward, we're going to have a distance of 0.1, okay, from here to here, 0.1. So we're having a charge q1, charge q2. Now I want to find the electric field strength or intensity at this point, okay, at this point. So if we should trace it for this q1, we're going to have something like this. Okay, for this q2, we're going to have something like this. Take note that the diagram is not drawn to scale. Okay, it is not drawn to scale. Now here is the coordinates. Okay, this is the y-axis and this is the x-axis. Now for this charge, remember it's a positive charge, so the flux are directed outward. We're going to have an electric flux line which designates the intensity. So it's something like this, okay, and then for this one it's going to be something like this. Now what will be the angle of inclination? What will be the angle of inclination? We could call here alpha and we could call here alpha as well, okay. So for us to solve, since you can see that there are slopy lines, we're going to make use of the angle. In our previous video I explained how we solve problems like this when we're having vertical lines or horizontal lines, and then I did one example mixed with a sloping line or a slant line and then a vertical line. So for this one, both lines are slopy. How we're going to do it? Okay, so for this case we're having an angle here alpha, which we have not found, and it is necessary we find it. Okay, from here to here 0.2, here to here 0.1, here to here 0.1. So we can make use of these two distances to find this angle, right? We could do it. Okay, so to find this angle, we make use of this two, that's tan. Okay, so remember your slope at 12. Okay, remember your slope at 12. Let's call it theta. Remember your slope at 12. So 12 is opposite of adjacent. So we're going to find this angle theta. That means tan of theta is, what is the opposite? 0.1. What is the adjacent? 0.1, which means theta will give you what now? 45 degrees. So here we're having what now? 45 degrees. If this is 45 degrees, also here should be 45 degrees, right? So then how are we going to find the net electric force? You see they are slopey, we have to solve the electric field flux on the horizontal and on the vertical, the mix of Pythagoras theorem. So on the vertical, the net electric field flux, this is going to be 0. But why is it 0? Okay, here is something you should understand. These two guys are spaced, okay, and then the distance for which we are looking for to find the electric field point at that particular point is at the center, at the midpoint. It just bisects this line. In fact, this line is the perpendicular bisector. This is the vertical line you're seeing here. So from here to here is equal from here to here, and we're having the same magnitude, which means on the horizontal, the electric field is going to cancel out at any point on the horizontal. So even if I take it here, on the horizontal, they're still going to cancel out. Notice that these two electric lines, when I resolve them, they will be facing this direction, horizontal, moving away from each other, okay? So they're going to what now? Cancel out at any point where they meet. And then for this case, they're also going to cancel out. So the EX at any point will be equal to what now? 0. Okay? How about EY? How then do we solve for EY? Now for EY will be equal to the electric field of this one plus the electric field of this one at any point here, okay? Now to do that, we are going to have E1Y plus E2Y. Okay, remember the formula for calculating the electric field remains E is equal to KQ divided by R squared. Okay, where R is the distance from here to here, and we already found this distance. Oh, we've not done that. Okay, if I should call this distance P, P will be equal to the square root of 0.1 squared plus 0.1 squared. So P is equal to, making use of the Pythagoras theorem, we want to find the hypotenuse. So that will be the square root of 0.1 squared plus 0.1 squared. Okay, that's going to give us a value of 0.1414. Okay, I'm going to get P equals 0.1414. Okay, that's the value of P. Remember, both sides are equal. Okay, so to solve that, we're going to make use of the formula KQ over R squared. So we have KQ divided by R squared. So R squared is going to be, what's the distance? 0. The distance is actually the same, so we could actually put the same R. Okay, that will make more sense. We have R squared. Okay, then now we're not just going to mix up the formula. Remember, this guy is slant, not vertical, not horizontal, so we're not just making this formula. We have to resolve it to the vertical. That is sine of theta. Okay, and we already found theta. What did we find theta to be? 45. We have sine of theta, which is in this case, okay, 45, plus the other one, exactly the same thing. So I'm going to have KQ over R squared sine of theta. Okay, that's what you notice. So from here, we're going to have, when you sum this, you have twice one of them. So EY will be equal to 2 times KQ sine of theta divided by R squared. So from here, we can plug in the values to give us EY then equals 2 times 9 times 10 to the power of 9 times Q is 10 to the power of minus 6, giving the equation. Sine of theta in this case is what? What will be theta in this case? Theta will be 45, okay? We've already solved for it, 45 degrees, divided by the distance is 0.1414 squared, okay? What are we going to get as the value of EY? That will give us 2 times 9 times 10 to the power of 9, okay? Times 10 to the power of minus 8, sine of 45 divided by 0.14. This calculator is just messing up. So we're going to have 2 times 9 times 10 to the power of 9. Okay. Times 10 to the power of minus 8 sine of 45 degrees divided by 0.1414 squared. Okay, that's going to give us a value of 1, 2, 3, 4. 1, 2, 3. That's going to give us a value of 6.365 times 10 to the power of 3 newtons per coulomb. Okay, that's going to be our value for EY. Now, to find the resultant, we're just going to simply say E is equal to the square root of EY squared plus EX squared. We already said that EX at any point is what now? 0. We've proven that already. So square cancels square root, so E is equal to EY. That means our final value for E remains this, which is 6.365 times 10 to the power of 3 newtons per coulomb. Okay, we'll as well approximate this to be 6 times 10 to the power of 3. Okay, depending on what is given in the examination or in the question. So that is how questions or problems like this are being solved. Okay, so we've successfully done the 3 problems, split into 3 videos. So you can as well watch this previous one to get more understanding and those other problems as well. Okay, they've been solved. So do it to like, share with your friends, and if you have a question, put it in the comment section. See you in the next video.